Manufacturing evolves to meet the demands of customers and novel products. Sometimes, this means machine shops need to change their approach to normal steps or processes, including how they set up to process parts they may have been producing with regularity. The advent of very hard specialty alloys and composites has been especially consequential for shops machining aerospace parts, dies and molds, or energy system components. Machining hard materials requires special attention to technique and tool design in order to achieve the expected results and performance standards. No matter how desirable it may be in terms of the finished product and its performance, some harder materials demand specific approaches, and the results may be less than optimal if the right steps are not taken during setup. Equally, the shop runs the risk of reducing the performance life of cutting tools. Tool designs. Successful machining for hard materials begins with wise tool selection. They must be rigid and offer high precision, and the tool must be matched to the different steps in the process and the geometry of the workpiece. Ball end mills. These are a good choice for roughing as well as finishing hard materials. With their large working radius, ball end mills help disperse heat as well as force, which reduces the likelihood of workpiece deformation. They help the operator get close to the desired net shape at a high operational speed. Bullnose tools. Hard material workpieces with flat and broad floors benefit from bullnose tools. The trade-off is that their smaller radius does not dissipate heat as well as you might wish, and it is more prone to causing chipping. Square end mill. Parts with sharply angled corners where the wall meets the floor usually will get the best result with a square end mill. This is typically the only time you may use one, however, as it tends to focus rather than dissipate heat and force. Roughing. To machine a hard material, it's usually wise to use the soft machining technique during the roughing phase. This means beginning work using materials that have not yet been heat treated. In this annealed state, the item is softer and easier to work with, allowing you to lessen the stress on the die or mold, or other hard material product. You can make the most of the roughing stage and reduce the required finishing work by selecting fast toolpath patterns that remove a lot of material quickly. Adaptive clearing is ideal for this and is a good choice for working with superalloys, hardened steel, and other hard items such as iron. Remember to count your flutes, too. End mills with at least 4 flutes are good for roughing hard materials, although 4 to 8 will further improve your results.